Hello everyone, welcome to the third video in this series. We'll start from problem 21. An ideal gas at temperature T in its rest frame is viewed from a frame moving with a velocity v with respect to the rest frame. In this frame, what is the temperature? So we can use Wien's displacement law, which says that lambda times T is equal to constant. So essentially from a rest frame, we have an ideal gas with lambda and T moving in a relativistic speed v. So due to the length contraction, the wavelength observed in the rest frame lambda prime is equal to gamma times lambda. Now in this frame we will also have the Wien's displacement law. So that means lambda prime T prime has to be equal to lambda T. So we find that lambda prime is equal to gamma times lambda times T prime is equal to lambda times T, or T prime, the temperature in the rest frame, is equal to T divided by gamma, which equals to T times square root of 1 minus V squared divided by C squared. So option A is the correct answer. Problem 22. We have 8 diatomic non-interacting molecules in a system. The diatomic molecules are rigid. The number of degrees of freedom is, so let's assume that the number of degrees of freedom of one diatomic molecule is n. Then the total number of the degrees of freedom of the system is 8n. Since n is a natural number, so this eliminates option A and option D. Now let's find what could n be. Assume that the two atoms in a molecule are free, then the number of degrees of freedom is 2 times 3. So this 2 is the number of atoms, and this 3 is the degrees of freedom for 3 translations. And now since these diatomic molecules are rigid, so we have one constraint. Essentially, the number of degrees of freedom of one diatomic molecule is 6 minus 1 is equal to 5. Hence, the total degrees of freedom is 8 times 5 is equal to 40. So option C is the correct answer. Problem 23. The Lagrangian of a particle of mass m in spherical coordinate is given by this. Which one of the following quantities is conserved? We observe that the coordinate phi does not appear in the expression of the Lagrangian. So phi is a cyclic coordinate. Hence its conjugate momenta del L by del phi dot is conserved. So option A is the correct answer. Problem 24. Which of the following quantities remains the same at every point of the elliptic orbit of a planet around the Sun? So we know from the Kepler's law that the angular velocity of the planet remains constant always. So option D is the correct answer. Problem 25. The Hamiltonian for a one-dimensional system is given by this. Which of the following statement is correct? So we find the dependence of time in the Hamiltonian by calculating the first derivative of Hamiltonian with respect to t, and this is equal to minus p plus a cos t times a sin t minus ax cos t. So at this moment the variable x and p may carry explicit time dependence, so we have to calculate those. We know that p dot, which is the derivative of p with respect to time, is minus del h by del x, and this is equal to a sin t. So this means that p is equal to minus a cos t. So we have found that the momentum is explicitly dependent on time. Let's find x dot this is equal to minus del H by del P, and this is equal to P plus A cos T. So now we put the value of expression of P here and find that this is equal to x0. So essentially x is constant. Now let's go back to the derivative of the Hamiltonian with respect to t, and if we see that if we put P is equal to minus a cos t, this term goes to 0, but this term survives. So the Hamiltonian is dependent on the time also. So neither linear momentum nor energy is conserved. So option D is the correct answer. Problem 26. What is the value of alpha for which the transformation is not canonical? Now note that the old set of variables must satisfy some Poisson bracket relations. Q, P is equal to 1 and the Poisson bracket of QQ and PP is equal to 0. The new set of variable capital Q and capital P must satisfy similar type of relation in order to become a canonical set of variables. So let's calculate such Poisson bracket. QQ is equal to minus sin alpha cos alpha Poisson bracket of small q and small p minus sin alpha cos alpha the bracket of p and q. So this is equal to 1, this is equal to minus 1. So essentially the Poisson bracket of capital Q and capital Q is identically 0. Similarly PP is also 0. Now let us calculate the non-trivial bracket of Q and P. So this is given by cos square alpha QP minus sin square alpha PQ. This is equal to 1 and again this is equal to minus 1. So essentially this bracket is equal to cos square alpha plus sin square alpha, which is equal to 1. So for any values of alpha, we find that capital Q and capital P are canonical set of variables. So none of the answer is correct. Problem 27. Two spaceships are moving towards each other with a velocity of 0.48 c each. What would be the velocity of the second ship as seen from the first? With respect to ground, assume that the first ship is moving towards right with a velocity v is equal to 0.48 c, and second ship is moving towards left with a velocity u is equal to minus 0.48 c. Now we use the addition formula of relativistic velocity. So the velocity of the second ship as seen from the first is equal to u prime is given by u minus v divided by 1 minus uv. Here we have used c is equal to 1. So this is equal to minus 0.48 divided by 1 plus 0.48 whole squared. If you calculate it, this would be minus 0.78. So option C is the correct answer. Problem 28. When sulfur nucleus is bombarded with neutrons, radioactive phosphorus and certain particles are produced. What are these? So sulfur 3216 plus neutrons n, this is 01, is going to phosphorus 1532 plus some x. So let's calculate the atomic numbers on both sides. This is 16, this is 15, so the atomic number would be 1 of x and the mass number must be 1, so this thing must be proton. So option A is the correct answer. Problem 29. A kaon K0 decays to a pair of pions. Given that K0, pi 0 and pi plus minus are pseudo scalar of particles, the lifetime of kaon will be around this. So we observe that the quark content of K0 is d s bar, and pi 0 is u bar and d bar, pi plus ud bar and pi minus u bar d. So essentially the strange quark here, strange antiquark, will be converted to u or d. So the strangeness of the particle changes. So this must be a weak process. The typical lifetime of a weak decay is 10 to the power minus 10 second. So option A is the correct answer. Problem 30. We have to find the equation of the plane tangent to this surface at 1, 1, 1. Assume this is the surface and the point 1, 1, 1 is denoted as P. We will find the normal vector first. Let n be the normal vector and assume R be another point that lies on the surface. So the vector PR must be perpendicular to n. So let's find out the normal vector first. So the normal vector can be found by taking gradient of the surface xyz minus 1. In the vector notation, this is equal to yz, xz and xy. Now let's put 1, 1, 1 for x and y and z. So this is equal to 1, 1, 1. Now the vector PR can be written as x minus 1, y minus 1 and z minus 1. So now we take the dot product of this vector with this to find the equation of the plane. So this would be x minus 1 plus y minus 1 plus z minus 1 is equal to 0, or x plus y plus z is equal to 3. So option D is the correct answer.